Ladies and gentlemen, we're going to give you some examples of gas laws. And here are the problems you may see. So what we have is PV equals nRT, and often you're going to have a problem with initial and final conditions. So we're going to isolate R, as you see here, PV divided by NT is equal to R. And now we could say, if we have initial and final conditions, we've got P1 V1 over N1 T1 is equal to P2 V2 over N2 T2. So now we have a way for beginning and ending. And I like to use and most tests will give you just the ideal gas law. And if you notice, if pressure and volume are constant, or I should say pressure, N and T are constant, so P1 V1 is equal to P2 V2, or volume and N is constant, so P1 over T1 is equal to P2 over T2. I mean, here is the basic gas equations all together. And use this equation, then figure out what's constant, and you should be able to figure out how to solve it. And this is what I'm meaning. It's that with this equation, if you eliminate the variables that are constant. Now, how do you know the variables are constant? There's two ways. One, they're explicitly stated that it's constant. Or two, is implied by not mentioning it. So there's two ways that we're going to know. And the hardest one is if it's implied. If it's implied, you got to figure out how you mean it's implied. And we're going to take a look at this. Here's an example. We have 4 liters of air that has a pressure of 500 torr. What would be the volume if the pressure was increased to 1,000 torr? So we have a volume, that's 4 liters. And we'll call that volume 1 since it's listed first. And we have a pressure, P1, of 500 torr. I'm not going to change it because I got torr on the bottom. So P2 is 1,000 torr. All right. And what would be the volume? So I'm looking for V2. N. T. We don't have anything in the problem that talks about pressure or the amount of gas we have. So it's implied, since we don't mention it, that these are constant. That they're not going to change. So this is what I mean by implied. Is it set up here in the question? Nope. Therefore, we're going to assume that's implied. So we're going to look at V1, P1 V1 is equal to P2 V2. Now let me come over here and where it's something clear. P1 is equal to 500 torr. V1 is 4 liters. P2 is 1,000 torr. And we're looking for V2. Come to this equation, take away P1 V1, divide both sides by P2, that will give me V2. So 500 times 4 divided by 1,000, that should give me V2, which should be 2 liters. And that's the answer. And this is what we're doing. Now, how do I get this, you may ask? Well, P1, if I use the ideal gas law, N1 T1 is equal to P2 V2 times N2 T2. This is constant. So if I multiply both sides by N2 T2, they're going to go away. So all I have is this. This is what we mean how strong this equation is. If they're constant, we don't have to worry about it. Now, I will give you a question where you have more than 3 variables changing. And this should be variables, not constants. That's a typo. I don't know what I was thinking. So we've got 3 variables that are changing. Look at what happens when this happens. So I have an empty gas cylinder that has a pressure 200 torr, volume 100 milliliters, and a temperature contains 0.2 moles of gas, keeping the volume constant. So V is constant. I said so. V is constant. Calculate the temperature of the tank. So we're looking for T. When you add 25 additional moles. So N1 plus 25 is equal to N2. And the final pressure is 9,500 torr. So volume's constant. So let's look at this. So P1 V1 over N1 T1 is equal to P2 V2 over N1 N2 T2. You know volume is constant, meaning that V1 is equal to V2. So this goes away. P1 is, go back here, 200 torr. So P1 is 200 torr. Well, hopefully pressure is going to remain in torr. Let's take a look. Yep. We got N1 is 0.2 moles. And T1 is going to be 273 Kelvin. I want to double check my temperature. Yes. And N1, N2 is going, we're going to add 25 moles. So 25 plus 0.2 is going to be 25.2. We're adding an additional 25 moles. That additional is going to means I'm adding more to it, and that's how much more I'm adding. And I got final pressure, P2, of 9,500 torr. I want T2. So T2 is what I'm missing. So come to this equation, P1 over N1 T1 is equal to P2 over N2 T2. I want T2, so let's multiply both sides by T2, get it over to the top. Now I want to divide both sides by P1 and then multiply by N1 T1. So T2 is equal to P2 times N1 T1 over P1 N2. So let's stick the numbers in. P2 is going to be 9,500. N1 is 0.2. T1 is 273. P1 is 200. And Pn2 is 25.2. So there are the numbers. And my final temperature should be in Kelvin. So, whoops, took my calculator. Let's go ahead and work on this. 9,500 times 0.2 times 273. We'll get 508,700 divided by the quantity 200 times 25.2. And I'm going to redo this because I mistyped a number. I realized I did it right as I hit the equal sign. So my temperature is going to be 103 Kelvin.